Let's have a look at questions 1 and 2 for starters here. We want to assign a swimmer, S1 through S5, whether they're like Anne, Bob, Charlie, not sure who they are, to an event or a race, backstroke, breaststroke, butterfly, or freestyle. Here are the times that they take to complete each of the events. So for example, swimmer 1 takes 37.7 seconds to do the backstroke event, and so on and so forth. And what we want to do is assign swimmers to events. Now, there needs to be a swimmer in every event. So we need one of the 5 swimmers to do the backstroke event, one to do the breaststroke, one to do the butterfly, one to do the freestyle. Okay. And then what we don't need every swimmer to do an event. So we need every event to have a swimmer in it, but we don't need every swimmer to do an event. We can also see that because there are 5 swimmers and only 4 events. So that wouldn't work anyways. Okay, so let's have a look at how we set this up. Let's just drop this over here. So here's kind of the template. I actually took that kind of assignment and network problem template from class. That one there, and I'm using that, and I just modified it a little bit. Okay, so one of the Excel examples that he posted here. Now, let's go and set this up. So what I'm going to do right here, all of these are going to be basically like a yes, no. Do I assign a swimmer to an event, yes or no? So for example, if this one's a 1, it means I assign swimmer 2 to event 2. And in this case, that's just the breaststroke. Okay, let's go do that then. So how are we going to set this up? Well, first of all, with all these network flow type problems, we do the sum across each row. Copy that down. Okay, so we add up all of these, and then we do the sum down each column. There we go. And then we pull it across. Okay, and what we're going to need here, because we need because we need every event covered once by one of the swimmers. If these are all 1s and 0s, let's say like that, we need 1 swimmer to do event 1. It doesn't matter which one of them here, but we need one of them to do that. So we need this to add up to 1. Okay, beautiful. So I am going to say in Solver that the sum across here has to be 1. That makes sure that that event is covered by 1 swimmer. And do the same for each of these. Oop. Okay, perfect. Perfect. There we go. Same idea down here. Slightly different though. We don't need every swimmer to do one of the events. So what we're going to do here is we're going to say that the sum down these columns, so looking at swimmer 1 needs to do at most 1 event. So what this is saying is you can't have swimmer 1 do more than 1 event, but you don't need them to necessarily do an event. That's covered by that less than or equal to 1. Okay, and then we'll set that up in Solver. God. And our total time is going to be the sum product between all these 1s and 0s. That'll say yes, no, basically for each of our swimmers, times that by the times, and that will give us our total amount of time spent swimming. Beautiful. So let's go pop that in Solver. So here it is. We've got the following. We're trying to minimize this total cost. Our variables are all of these guys here, B2, to F5. Then for our constraints, I'll just go and redo these. You can see them. Okay. Same with all the network flow here, or a bunch of the network flow. You need to think about kind of how your flow out and in is going. And in this case, we want all of these sums to be exactly equal to 1 each. You could just put a 1 there, or you could grab these ones, whichever you prefer. And add that. And then here, the sum down each of these columns needs to be less than or equal to 1. Again, you could just type 1 instead of grabbing these cells here. Click OK, simple XLP, and click Solve. And now, one last note, these variables should all be binary. They should be 1s or 0s. Now, because we are forcing them to be less than or equal to 1 in the sum and here too, and because of our right-hand sides are all integers, we actually don't need to specify that these will be binary in Solver. But yeah, just try it either way. And if you don't get whole numbers for all of these values, when it's like a yes, no, a 0, 1, then you could go tell Solver that these are really binary variables or integer variables. So again, here, if everything's all integers, these are all integers, these are all integers, then the solution should be integers also for these types of problems. Okay, and I get 126.2 for my answer. Okay, let's now look at question number 2, or sorry, forgive me, question number 3 really, in the quiz. So now, just a variation on the previous question. We now have 2 weeks in a row of the same set of events, where we have the same problem, where we have basically the swimmers and the events here, and we don't want one swimmer to do more than one event. They can do at most one event, and we don't, and we need every event to have a swimmer in it. And then there's one more thing here. We need a swimmer to not do the same event 2 weeks in a row. So for example, swimmer 3, if they compete in the butterfly in meet 1 here, they shouldn't do that in meet 2. They can't compete in that same event. Okay. Now I'm just going to be lazy and just call the events event 1 through 4. Really, that's all the different types of swimming events. Okay. And if you want, we could call this meet 1 and meet 2. If you prefer here. Okay. This is meet 1 and meet 2. Okay. Now, we still have a lot of the same setup. Really, I just copied the question twice to make this happen. And so, really, we have all of these guys needing to add up to at most 1. This sum right here, we need each swimmer to do at most 1 event. And again, we need each event covered by 1 swimmer, so the total of the swimmers needs to add up to 1. So those are the same as before. And let's have a look at those in the context, those kind of constraints, if you will, in the context of formulas. Okay, so let's see here. These were the 3 correct formulas. It's definitely easier to do in hindsight too, right? And what we're looking at when we're summing up across the row here, that needs to sum to exactly 1. That is this constraint right here, this guy. Okay, so across each row, we need exactly once that the event is covered. And basically what you're doing then is you're summing across I. So I is really your swimmer. Okay, so let's say for S1, we're going to say I is equal to 1. And let me pause that and fill these in. Okay, so here we are. So really it's I from 1 to 5 for each event. And we're going to call the event numbers K. And now what is that J in there? Well, let's look at that too. Okay, so the J is our event number. So 1 through 4 for each of the swim meets. So what we're going to do, notice here we're summing over I. That means we're leaving J fixed. So let's say J is 1, for example. And let's say K is 1. Then we're summing over I. Well, what the heck does that mean? That means we're grabbing this top row. Or if J were 2, K is 1, we're grabbing this row. And summing up all of those values, and they need to sum to exactly 1. So this is just giving us that constraint that within each meet, the event needs to be covered by exactly 1 swimmer. That is this guy here. That is this constraint. Let's just move it down then. Good. Okay. Now, next one is this one. It's a little problematic, so I don't know if you've noticed, but Stephen has just updated this. This is actually a typo. So he meant actually for this to be a 4 here. So this one, same idea, but now within each swimmer, if you will. Or sorry, within each swimmer, within each week, if that makes any sense. So now what we're doing is we're varying J. So J goes down the column. So now we're varying J from 1, this should be a 4, up to 4. So J is 1 to 4, and we're going to fix I and fix K. So for example, let's look, so we're only fluctuating the J because that's what we're summing over. So let's say for swimmer 1, meet 1. The total here needs to be at most 1. Again, this is the case where each swimmer can swim only 1 event at most. They don't have to do the 1 though, because there's 4 events and 5 swimmers. So we can't have them all do an event. How we set this up is that we need each swimmer to do at most 1 event. That's that less than or equal to. So this guy right here tells us that each swimmer competes in at most 1 event per meet or per week. And that is this guy. And again, that's supposed to be a 4 up here instead of a 5. Okay. And again, that's because there's only 4 events and not 5. There are 5 swimmers, but only 4 events. Okay, finally. So this is the new constraint now from meet to meet. I'm just going to scroll back up here for a sec. You can't have the same swimmer doing the same event each week. So for example, swimmer 3 ended up doing event 1 here in week 1. So swimmer 1 cannot go do event 1 in week 2 or in meet 2, if you will. If you wanted to set this up in Solver, what you need to do is say, hey Solver, you're going to go compare each to each here. So you're going to compare the same swimmer with the same event each week and say that these two cannot be equal. And you do that for each event and each swimmer. So that wouldn't allow swimmer 2, for example, to compete in event 1 both weeks here or in both meets. And what that ends up looking like is this right here. So what this is doing is fixing the swimmer and the event and comparing the 2 meets or the 2 weeks. So from weeks 1 to weeks 2, they cannot be equal. So you could also just define that in Solver. Say, hey, Solver, don't make this guy equal to that guy. The other way you can think about it is the following. Let the sum of those 2 be at most 1, meaning they can only do this exact same event once. So again, you're fixing I, fixing the J, so you're talking about a specific swimmer and a specific event. You're not fluctuating those. And then you're comparing from meet 1 to meet 2, and you're saying at most 1 to let them do this event at most once in between these 2 meets. And at most once, because they don't necessarily have to do it. For example, swimmer 2 did not compete in event 1 in either week. So let's say, let's clarify it this way. Swimmer I does event J at most once between the two meets is what this guy says. Sorry, and I'll fix that after here too. Beautiful. And that is that constraint. Let's now look at the next question here, question 4. We're talking about political districts. Now, what you have to be really careful of with this one, and I, in my foggy brainness, missed this wording in this question when I did it too. So very important is the following, that a district can cover more than one city. Okay, so let's say District 1 here. Let's just go circle it. District 1. It can cover cities 1 and 2. Okay, sorry, that's really messy. Okay, and so this is critical to understanding this. So if you select District 1 to be one of the representative districts, then inherently it represents City 1 and City 2. So a district can cover more than one city. Let me just pause this and fill this comment in. Okay, so there we go. So district can encompass or cover more than one city. Okay, but it's important to realize that a city cannot be covered by more than one district. Okay. Okay, so this is important to realize here. So for example, if we have District 1 that we've selected, so we're going to select districts as well. If we have District 1 that we selected, then it's going to cover cities 1 and cities 2. So if that's true, then guess which district we cannot also choose? We're not going to be able to choose District 2 then. Okay. In this case, we're going to have to X that out. Let's just make this font a bit bigger. Beautiful. So then we cannot select District 2 if we've selected District 1 because it's already covering City 2 for us. Okay. Now, let's go back here and have a look at what we're thinking about possibly doing. So first one here, let's go link District 4 to C4, the first option. Or sorry, actually, you could really do this in any order. Okay, and let's do 4 to C4 and see what happens. Okay, so if this is the case, then actually I've kind of spoiled the surprise. C1 always needs to be covered by a district. The only district covering it right now is District 1, so we must make this selection that District 1 is one of the ones we choose. So again, we're choosing our districts. Okay, so we're going to choose District 1 because we need City 1 covered, and the only way to cover it is with District 1. Okay, now what else are we going to do? So we've got District 1, so what we have to do is not choose District 2 because it would double cover City 2, and that is not allowed. Okay, so we don't choose District 2. Okay, now let's look at Districts 3 and Districts 4. So District 3 here connects to C4, so does District 4. Now that we can't choose District 1, well, what about C3? That's a problem. So C3 here is never covered. This is problematic. Okay, we're never going to cover C3. just had a big question mark here. It's never going to be covered. So this is our problem. Okay. So C3 will never be covered with this kind of plan, if you will. Beautiful. So if we link D4 to C4, then we're not satisfying the condition that every city needs to be covered by a district. Now for C4, no problem. We could either choose District 3 or District 4. Either of them cover C4. So that's no problem. Doesn't matter which one you switch or you pick there. So C4 can't be covered by D3 or D4. Beautiful. Good. Sorry, that's a bit rough there. Okay. But again, this is going to fail because you can't have more than one city connected to one node, and C3 is never covered. So I'm just going to put this comment somewhere else. This is getting messy here. But yeah, so basically what happens is that this one is a fail because we don't have all of the cities covered. So it's a fail because C3 is covered. We don't even actually need to worry about how C4 is covered now because this failed. We can't have C3 not covered. Okay, now same idea here with the next possibility. Or sorry, yeah, same idea. We go and work this through. Beautiful. And now let's now link D4 to C3. So I'm just going to go through all the options here. It doesn't matter which order you think about them in. Beautiful. Okay, so this is the next option where we're linking D4 to C3. And a little recap here. Before we do this, little note that D4 to C4 was a fail. Okay. And now we're going to link D4 to C3. Beautiful. So let's see what happens here. So you could go through the list here and see what's going to be covered. So D3 covers C4. That's perfect. It's the only one that does now. So we're definitely going to select D3. Okay. And that's going to happily cover C4 for us. Perfect. Now, to cover C3, we could have it covered by D2 or D4. And actually, this one's great. What we could do, actually, no, I take that back. I'm so sorry. C1, let's look at that next because it feels like there's a bunch of things we can do. But let's also realize the only way to get C1 covered is through D1. So we have to select District 1 as well. And District 1 also encompasses City 2. Okay, so we can't have that covered by District 2 because it's already covered by District 1. So we cannot select District 2. So we need City 3 now covered. So we're going to cover that with District 4. Beautiful. So we're going to have all the cities covered. We don't need District 2. We would choose District 1, 3, and 4, and everything would be great. So D3 to, D4 to C3 is a pass. And ideally you would select Districts 1, 3, and 4 there. Okay, moving on. Beautiful. And actually, I should wait to write that. Sorry. There we go. So D4 to C3 is a pass. Beautiful. Now, next one. So now let's look at D4 to C2. So really, again, you can do these in any order that you examine them. But yeah, I'm just going to go up. Okay, so now let's look at this one. So again, C1. The only way C1 gets covered is with District 1. Still, same as always. It's only getting covered by District 1. It's the only one that connects to it. Nobody else does, or no other district does, so we have to do that. We have to link D1 to C1. That means that C2 gets covered by D1. That again means that we cannot select District 2 here, okay, because we can't have C2 double covered. And then that also means because D4 would cover that, we cannot select D4. Okay, now we can select D3. That's great. And that's going to cover City 4. Okay, great. Problem though, what about City 3? So again, City 3 is not being covered. Okay, so this is a fail. If you link D4 to C2, we can't cover all of the cities with districts. So again, that is a fail. Okay, and final one here. Let's now link D4 to C1 and see if that passes. Okay, so what I like about this one is now C1 can be covered in two different ways, either by District 1 or District 4. That's good. Okay, now the problem one has always been C3, so let's look there first. So C3, we need that one covered. The only way to get it covered is with D2. We're now able to choose this pairing because C1 can get covered by another district other than District 1. So we're going to choose District 2, and it's going to cover C2 and C3. Beautiful. Now we need C1 covered. We cannot choose District 1 because it would cover C2 again. So we're going to link C1 to District 4, or if you will, choose District 4. Beautiful. Okay, that leaves us with C4 to get covered. Well, that's nice too. No problem there because D3 connects to C4. Beautiful. So this is a pass. Okay. And so D4 to C1 is a pass. That concludes this question in perfect timing.